So in the last video, we did some sample problems that involved us converting from moles to mass and mass to moles. We had to use our formula m is equal to n times molar mass, or we could use our formula moles is equal to m divided by big M, so mass divided by molar mass. And we had finished off with this question here. We just ran out of time, but if you continued through, you would have seen that your final answer, when moles cancel out, is going to be 118.958 grams. In this video, we're going to do a different type of problem that still deals with the mole, but rather than convert from mole to mass, we're going to convert from mole to number of particles, or number of molecules, or number of atoms, or number of ions, and vice versa. We'll convert from number of particles to number of moles. So you need to remember the Avogadro's number when you're doing these problems, the 6.022 times 10 to the power of 23. So for number of particles, there's another variable you need to remember, and it's big N. Big N means number of particles. So our formula to find number of particles, big N, is going to be the number of moles multiplied by Avogadro's number. Let's do a few sample problems together. You're given 3.84 times 10 to the power of 24 molecules of copper 2 nitrate. How many moles of copper 2 nitrate do you have? So in this case, you're asked to find little n. In this question, you're given big N, the number of molecules of copper 2 nitrate. Big N is 3.84 times 10 to the power of 24. I'm just going to write down CuNO3 2 copper 2 nitrates. How many moles do we have? So that's what we're looking for. We also have another number that we're not told in the question, but you should know by now. If you don't, go back and review it. Avogadro's number, which is 6.022 times 10 to the power of 23 particles per mole. Now, I'm going to change particles to what we're dealing with. We're dealing with the particle in particular is CuNO3 2. Per mole. Now, what you'll notice is we're not being asked to find the number of particles. We already have that. We're just trying to see how many moles we have. So we have to rearrange our formula. If you rearrange your formula by doing your division, you'll get the number of moles is equal to the number of molecules divided by Avogadro's number. And when we do our unit calculation, you'll see why that makes sense. So let's plug in our information. Number of moles is equal to the number of molecules. So we have 3.84 times 10 to the power of 24 molecules of CuNO3 2. When you put this in your calculator, put the scientific notation in brackets, divided by Avogadro's number, 6.022 times 10 to the power of 23 CuNO3s per mole. NO3 2 per mole. So you'll notice you can cross particles of CuNO3 out because you have one on top of the other. And what you're left with at the end is number of moles, which is great. So plug that into your calculator. First, you'd open the brackets, put your first scientific notation, 3.84 times 10 to the power of 24. Close the bracket. Divided by, open the brackets, 6.022 times 10 to the power of 23. Close the brackets. Equals, and you get 6.388 moles. So you have 6.38 moles of CuNO3 2. So in 6.38 moles of CuNO3 2, you have 3.84 times 10 to the power of 24 particles of CuNO3 2. Here we have another example. You're given 20.2 moles of nitrogen atoms. How many atoms do you have? So you're given the number of moles. You're given N. Write that down. 20.2. And write your unit down, mole. You're also given, because you always know this, it doesn't change, it's a constant, the Avogadro's number, 6.022 times 10 to the power of 23 particles per mole. And the particle I'm dealing with in this case are nitrogen atoms. So I'm going to put N per mole. And what I'm being asked for is how many atoms are there? I'm being asked for big N, for the number of particles. And so you can use your equation that you have up here. N is equal to little n times Na. So N is equal to little n multiplied by Avogadro's number. You can plug those numbers into your equation. Big N, number of particles, is equal to 20.2 moles multiplied by Avogadro's number, so 6.022 times 10 to the power of 23 N per mole. Nitrogens per mole. Mole over mole cancels out, and you're left with the number of nitrogens. So you can plug in your numbers, 20.2 times brackets 6.022 times 10 to the power of 23, close brackets, and you get 1.21 or rather 1.22 times 10 to the power of 25 particles of N in 20.2 moles. So the reason I knew to go for Avogadro's number is because I was asked for number of particles, and I had the number of moles. If I have the number of particles, or if I have the number of moles, and I want to find the number of particles, all I need is my Avogadro's number. I can do the multiplication, and I get my number of particles. So you should be able to attempt the other problems. I'll start you off with a few, and then afterwards you can move through the rest. Two of them require a bit more thinking. So this one here, you should be able to do no problem. These two here, you might need to think a little bit about what a water molecule looks like. So let's attempt these together. First, pause the video, try it yourself, and then afterwards, continue the video so you can see if you're on the right path. You're given 17.9 moles of water. 17.9 moles. Write that down. Of water, and remember that water is H2O. H2O. And you're asked for number of molecules, big N. And you have Avogadro's number. I'm not going to write it out again, but you have Avogadro's number. You know what that is. So now you can write that big N is equal to number of moles times Avogadro's number. So big N is equal to 17.9 moles times 6.022 times 10 to the power of 23 water molecules, H2O molecules, per mole. Mole over mole cancels out, and your final answer is 17.9 times 6.022 times 10 to the power of 23, 1.078 times 10 to the power of 25 water molecules. So we're going to have to use this answer to help us solve the problems that come next.